Okay, this is section 4.2. We're going to be talking about numerals in bases other than 10, and we're going to be converting back and forth from base 10 to base 7 to base 10, etc. Okay, changing numerals in bases other than 10 to base 10. The base of a positional numeration system refers to the number whose powers define the place values. And I know you're saying, what? What does that mean? So for example, for our regular number system, we would have the number 23. And what that means is 3 times 1 and 2 times 10. Since this, the 2 times 10, we say it's base 10. Base 10. But in other bases, for example, instead of multiplying by 10, we multiply by powers of 5, we say it is base 5. So, for example, if I have 2, 3 base 5, I still multiply this times 1, but I would, instead of multiplying this by 10, I would multiply by 5. If I had another number over here, I would multiply by 5 squared. If I had another number over here, I would multiply by 5 cubed, etc. Powers of 5. The Babylonians, they did 1 60 60 squared. We do 1 10 10 squared. In base 5, we do 1 5 5 squared. So, process to change numeral in a base other than 10 to base 10. Okay, first thing we have to do, find the place value, multiply, and then add them up. So we've done this before. It's just we're now multiplying by powers of 5 instead of powers of 60. Notice this means base 8. Another way of writing base 8 is to have a subscript, which means small and down. We could also write the number 8. So if I wanted to write this a different way, I could write it like that. So I could either write base 8 like this, or I could write base 8 like that. Now, since this is base 8, my positions are going to be powers of 8. As always, the first number on the right is always times 1. Next number over. Well, with our regular system, we would multiply by 10, but since this is base 8, we're going to multiply by 8. The next number over, we're going to multiply by 8 squared. The next number over, we're going to multiply by 8 cubed, etc. So, the 6 gets multiplied times 1. Number to the right always gets multiplied times 1. So we have 6 times 1. And notice I'm working right to left. It's easier that way. Next number over, 2 times 8. Next number over, 7 times 8 squared. And the next number over, 4 times 8 cubed. So we've done this process before. We did it with the Babylonians. We did it when we were doing regular numbers. This time we're just choosing powers of 8 instead of powers of 10 or powers of 60. So we would multiply those out. We would multiply 4 times 8 cubed, and 4 times 8 cubed is equal to 2048. 7 times 8 squared is 448. 2 times 8 is 16, and 6 times 1 is 6. And we're going to add those together. And, okay, Now technically I should write a little 10 down here to indicate that I'm now in base 10. Base 10 is our regular number. Anytime we talk about it, we're talking about base 10. Anytime we talk about a number, we're talking about base 10. So technically we should write base 10, but if it's assumed, if there's no base here, that we're talking about base 10. So you can put the 10 or not, it doesn't really matter. Okay, let's do another example. We are in base 12, and we want to convert to base 10. Well, let's think about base 12. Base 10 has 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So those are all the single digit numbers, okay? And there's 10 of them. Don't forget about the 0, okay? So there's 10 single digit numbers in base 10. Well, what happens if you have base 12? We need 12 single digit numbers. So how would we indicate the quantity 10 with only using one digit? Okay, one symbol to indicate the quantity 10. Well, it turns out we use letters. So A would represent the quantity 10, and notice this is a single symbol to indicate this quantity. If I want 11, then I would represent that with a B. And that gives us 12 symbols to use in base 12. Whenever we talk about a different base, so base 12 for example, the largest number we go up to is 11. If I have base 10, the largest number I go to is 9, because remember you got to add in that 0. Don't forget about the 0. So if I have base 6, the largest symbol I have would be 5. 2, 3, 4, 5. If I have base 3, the largest symbol I have is 2. 0, 1, 2. So this means I have 3 symbols. Don't forget about the 0. All right, so let's go back to base 12. All right, so in base 12, A represented the quantity 10, and B represented the quantity 11. Okay, so if I have A, that represents the quantity 10, it is in the ones place, so I'm going to take 10 and multiply it times 1. Now I have 3. Remember, we're in base 12, so we got to do powers of 12, so I'm going to take 3 and multiply it times 12. Okay, the B is in the 12 squared place, so B represents 11, so I have 11 times the 12 squared. Wrote that too close together. And then I have the 4 in the 12 cubes place. 4 times 12 cubed. Okay. So now it's just a matter of calculating what we have. 4 times 12 cubed is 6,912. 11 times 12 squared is 1,584. 3 times 12 is 36. And 10 times 1 is 10. And we add those together. And we get 8,542. We started in base 12, we're converting to base 10. So remember, this number right here tells us the what we have to multiply by and the powers of them.